Hi everyone. So in my previous video that we talked about getting the data from the GCP cloud storage from the bucket. Okay, it was a simple text data, and doing the embedding over there and push the data back to the our target vector database, that is Google BigQuery over there, and we perform a simple search to get the result from the vector database again back to us. So today we'll be extending this part. So what exactly we are going to do is that still the workflow remain, the primary portion of the workflow remain the same actually. So there is absolutely no changes. So we'll be still using the GCP bucket over there, and there are a couple of text files, a similar text file, and we'll be doing the embedding and push the data to the vector database over there. But once we are entering to the vector database, I will alter the document to push some kind of metadata over there, so that now this time we can search with the content as well as with the metadata filter being allowed over there. Okay, that's the slight change over there. And after that, once we get the our RAG output back from the vector database, then we are not going to return to the user right now. Rather, what exactly we are going to do that we are going to push this RAG output to the LLM over there. So let the LLM get the context, means the context is the RAG output of our query, and the output will go to the LLM to give the LLM the context with the question, means the query the user is finding over here, and LLM will give us a good response, expected good response from the context and the query. Okay, so that should be our workflow for today. So so this is a very simple diagram. Now if I move, open my workbook over here. So if you remember, I have I have this particular workbook previously. So it's fairly simple, reading the data from the GCP bucket that I talked about. What is the type? We'll see the type. What is the property? That become important because we'll be pushing the metadata information. So we need to see what exactly the metadata is containing and what we are going to put it over there. So here we will be adding some kind of metadata to facilitate the search facility by the metadata this time, and thereafter they are embedding similar thing that we have done with the previous step also. Then we will be creating our vector database. Then we will be adding those documents, means this metadata added document pushed to the vector database, and we will be performing our search. Now this time the search will be on the metadata as well as with the content. So there is a difference in this particular step, and thereafter we will be going to create a retrieval from our vector database, so that we can retrieve the data by our query, and we will push the data to the chat model so that it can get us back the response what we are querying of. So that's the simple flow. So without wasting any more time, let's go for the demo. Okay, so now first thing first, so here all the libs, necessary libraries of Python that is being needed to execute this particular demo. So you will find in this particular section all the libs are over here, and whatever we are importing, it's already over here. So only we just need to execute this. I have previously executed the same. So let's see. So it will take some time. For the time being, let's move on to let me show you my GCP structure also. So here is my GCP project. Okay, and if you remember, we are using this particular storage account or GCP bucket over here, and here are some text data. So this text data will be consumed by the vector database after the embedding. So that's the purpose of it. And this is my BigQuery. So as you see, there is no data set. It's completely empty right now. So we'll be creating all those steps. Let's see whether our import is complete. Yeah, it's done. So I'm just clearing this output. Okay, fine. Now we'll be importing all our leaves that is necessary for this particular demo. Okay, So only this thing is needed over here. Another change I have included is that previously we were hard coding, the project name or the bucket name in the particular code, but that's not a good practice actually. So what I have done actually, I have created an environment file. Okay, so one particular environment file, the environment file is containing all our necessary values like the project name, the bucket name, all the stuff over here. So I'm just from this particular library, .NET .env. Okay, you just need to call this particular load env to load the environment variables. Okay, so that's a slight change from the previous demo. So that's a best practice as well. So we are not putting any kind of hard-coded value in the codes, rather we are getting from the environment variable or environment file. Okay, so let me populate my environment variables. It being populated. Now I'm not explaining these things right now for today, because we have already discussed in the previous video that how to get the data from the GCP bucket and what are the purpose of this. So I'm just specifying the project name and bucket name over here. I'm going through this section very quickly because it is already included in the previous video. Okay, so just we need to run this out to get the documents I have shown to you, right? So here are my documents. So as you see, these are all the text files, simple text files. So it can be PDF, can be PPT, can be other artifacts also. So for now, for this particular demo, we are only dealing with the TXT file. Okay, so let's see. Okay, it is still loading, so it will take some time. Fine, not an issue. So we have to wait for this to be completed. Okay, so I'm also printing the whatever document I'm getting. So if you touch this particular method, you will see that it is giving us the document from the GCP bucket, those text files. Okay, so if you're you are storing more data into this particular GCP bucket, so the more put the content over there, the more time will be consumed to get the data from the GCP bucket. Okay, so that's the catch on it. So you can try it at least 1 or 2 files. So I'm trying with, I believe, 1 2 3 4 5 6 7 files right now over here. Okay, it's still loading. Okay, still loading up for us. Okay, let me show you, in meanwhile let me show you one particular thing that you may be interested will okay, so the data has been loaded for us. Okay, so it has been loaded from the GCP bucket. As you see, 1 2 3 4 5 6 7. Okay, and you see these are the source. So as you see clearly, metadata is containing only the source over here. Okay, so I know it is very clumsy to see the things over here. You may not be able to view all the things. That is why I have created this kind of things over here. So we are taking only 0, means the first item in the list. Okay, and let us print it out. Okay, so what is the type of it? So the type of it, again, it's a LangChain code document. So LangChain is a basically is a abstractor library, so which can work with Azure clouds, Azure ASH, AWS and GCP, all the things. So it's an abstraction, so it will return back you the LangChain code document. That's the benefit of using the LangChain. So that today I'm working with the GCP, right? Tomorrow I'll be working with Azure or AWS, but I need some kind of consistency to get my data and do my coding, right? So that's a wrapper. LangChain is a fantastic library to work with the AI services. So I highly recommend that. So we are using this out over here. Now as you see, let us print the particular property of one particular document. So LSC doc 0, that means we are going for only one document to see all the properties. Okay, let's see what it contains actually. As you see, every document in this list of document is containing ID, metadata, page content and type. Okay, so you see the metadata here. Okay, so the metadata is only containing one particular tag, that is called source, means the source of the GCP bucket. Okay, now here is the page content, means the content of the particular file that we have downloaded from the GCP bucket, okay, and type is a document. So metadata is not containing any other information over here, okay. Now what exactly we are going to do, that in the next cell our objective is to populate this metadata with another information. So for now I am putting a simple information is called ID, means it will push back the ID of the particular document in the list, okay, means, and populate with the ID information, okay. So let me run on it and show it what is happening. Now if you print the var of this particular, so var is a function which print the property of a particular object, okay. Now you see that in the metadata, previously in the metadata, or you can so ID, you see now it is getting the ID, but previously you see there is no ID in the metadata section. As you see, there is only source. Now if you look at this metadata portion, you will see up to this, okay, you will see that source is here, that's fine. Now we are pushing the ID, means the first document will eventually have the ID of 0, okay, and from 0 to 6 means there are same 7 documents out of there, right? So the ID started with the 0, 0, 1, 2, 3, 4, 5 and 6, okay. So we push some information into the metadata so that we can facilitate the search, because we have told that we'll be searching by the metadata also for today, so, and if you want to see all the contents over here, so here is the content of all the files, okay. Now this portion is already familiar to you from the previous video, that I am pushing all the GCP information over here. So another information I have added, actually previously it was project ID, region, dataset and table, because we'll be creating the big table dataset, right? So we'll be specifying the region, the dataset and the table which we are going to use, okay. And one particular information extra has been added, it's called the Google API key, because we will be talking to the Vertex API chat, okay. So for this communication, to talk with the LLM, we need the Google API key. If you are using like ChatGPT Open API, so there is also a key to talk between these LLMs, right? So it's a similar thing. So it is coming from my environment file, so I will highly encourage you to put all the hard-coded value in the environment file, and then call the environment get in env os.getEnv to get the value from the environment file, okay. So let me populate my GCP information. So it's being populated over here. Now embedding, you all know what is embedding, so I'm not going to talk with much over here. I have already discussed in my previous video, we can refer it back, okay. Now we are going to create the vector database, right? So here is my vector database, right? BigQuery client. So we are giving the project ID, the region and the dataset, and if it is exists, then it's okay, okay. So we are creating the client and creating the dataset, okay. Hold on, let me show you. Now you see there is nothing, right? Project training, there is no dataset, okay. So let it complete, okay. Now vector dataset has been created. Let's see, go to back to GCP. Now it is not showing. Let us refresh this one, okay. Just wait, get the refresh content, okay. Now fantastic, okay. Now you see project training, under there here is a dataset, so that we have created the dataset, okay. But dataset does not contain any kind of table or any kind of data for now. We will be creating those out, okay. Now go to our code. All the necessary links are being over here, so you can read it more out. So I'll be pushing this particular code to the GitHub. So I will be pasting the link to the video also, so that you can download the particular this particular notebook and have a go through it with all the necessary information. Push it back over here. You can go and read more over from this particular articles that I am referring to, okay. Now let us create the vector database, okay. So it is a code for creating the vector database, and we have already discussed in my previous video what is the Euclidean distance and all the stuff. Please refer to my previous video. I'll also put a link to the previous video so that you can refer back to it, okay. So let us create that. So once that is being created, then we are going to see a particular table under our data set, so we are creating the vector database and the table. Okay, so let it be complete first. Yeah, now it's completed. So if I move back to my GCP one more time, as you see, there is no vector data. So let us refresh the content. Okay, now you see the table has come up. Okay, but if I click on here, you will see that this table is containing doc ID, metadata, content, and text embedding. 4 fields are there. Okay, but this should be empty because we have not pushed any kind of data yet, right? So here you see, we have not done this particular step, so there is no document inserted in the vector database. So we'll be seeing the blank thing. Okay, so if I go over here and try to give you a preview, okay, so there is absolutely no data. That is what is right we are talking about. Now we'll be putting the data into the vector database. Okay, so let us run this particular code. So what exactly we are doing, we are getting the vector database and we are adding the document, that is the LST doc that we have created in the previous step. Okay, so with the metadata information, here is the LST doc for us. Okay, LST doc, this one, right? So let us push this LST doc to the vector database quickly. I am not wasting my time because as every time I'm telling you that we have already discussed this particular step in my previous video, so I'm not wasting the time over here. I want to just give you the, so now if you want to let's refresh it one more time. Okay, refresh the content. Okay, now let's see. Okay, hold on, it will show the data. Data had been inserted over here. Okay, now in the preview we'll see the data, right? So as you see, this is row number 1, means the first document we are talking. Okay, now the doc ID has been generated. Once it has been inserted to the vector database, it has an ID. Okay, so the metadata, right, we have created the metadata, remember? Okay, so ID is 0 for the first one, right? This is the content that, okay, and this is the embedding format of the content. So you remember that we talked about the vector database, that it's a numerical representation, right? It's a data that is being represented into the vector database, and that has a concept of numerical. It's not a numerical format, rather it's a particular coordinate, okay, in the vector space. So that is being referred by these numerical numbers. Okay, so this all data, okay, are converted into the vector database, vector space right now. So this is the number row 1 over here, and if you scroll down, you will see a lot of rows are being created over here. You see the row 2 also. Okay, so the data has been inserted over here. Now what we can do, now we will be coming back to our code again. Okay, so now this is the search. Okay, you remember that in the previous video we have done the similarity search by vector with the query vector only. Okay, now I am adding one particular filter over here. Okay, so this is the metadata filter. If you remember that this particular metadata where we have been generating, if you go over again over here, and you will see that this metadata is containing this particular ID field right now. Okay, so ID3 means we will be targeting this particular. Okay, so we are passing some kind of custom filter to our search right now. Okay, so with filter and without filter. Okay, now this particular red val, now it is not accepting any kind of filter, so I am querying for this particular query is called SNBOS. Okay, so what exactly I am trying to do is that I want to print the return value over here, and also I am pushing the return value to a JSON file, so that for your better understanding, so that you can understand what is the JSON looks like. Okay, so let's run. I'm running without the filter for now. It's only the query that we are firing. It's a numerical, it is text query the query will be embedded automatically by the same embedding that being used by the vector database, and it will do a vector matching, okay, a distance matching between the target vector and whatever we have in the vector database, and will give us the semantical output from the vector database. Okay, now it will be calculating on the Euclidean distance, because we have specified the Euclidean distance above when we are creating the vector database. Okay, so now you see this is the data, it is coming back to us. Okay, now I know it is very hard to see. Okay, I can copy it to the notepad and show to you, but that is also let's say this, I am bringing one particular JSON file. So you see this is the JSON output, you see vector search or JSON. So this is the search result right now. As you see that as we search for, it is returning 1, 2, this many document from the vector database. So remember, you have the 7 document in the vector database, right? So we are getting 4 document out of it. Okay, now if you open up this particular section, this is the first one that has been returned. Okay, and its ID is 5, so it is targeting for the 5. Okay, so 5 means this snboss.txt. okay, 6 means it is snb and einstein.txt, 0 means d1, and 3 means maxwell work.txt. okay, now if you want that I'm not interested about all the stuff, but really I'm thinking to target one particular ID. okay, in my return, I don't want 4 return. okay, rather I will be focusing for passing a particular filter. So a filter can be anything right now. So right now we have a filter in the metadata, that is called ID, because we have generated the ID. okay, now while you are creating the metadata, you could have numerical filters, like any tags. Maybe you are referring to some author, right? So maybe author name, okay, that can be a tag. Author email address can be a tag. Type of the document can be a tag. okay, or region, source region of the document can be tagged, US, India, UK, whatever you say. Means you can put whatever custom data you need to push on the custom data. okay, and metadata will be populated based on your custom data, so that while you are performing or searching the query to the vector database, you can also pass the metadata filter to it to narrow down your search for a particular metadata search. So let us do the thing first. okay, so now what we are going to do, we are going to comment this particular line, because as you see it is not accepting the filter. Now we are opening up the second line. You see the filter has been passed. What is the filter? We are targeting the ID 3, means we are targeting the document which has an ID of 3. okay, and we are narrowing down, as I say, we are narrowing down the search result right now with some custom filter being applied. okay, so let us run it. Okay, fantastic. We have run it successfully, executed and returned back as the desired result. okay, now so you see now we are only returning the ID 3, right? So this is how the filter will work on searching against the Google BigQuery. So you can push as much as a metadata if you want, so just to narrow down your expected search result. Because remember always, this kind of vector search, if you are using any cloud environment like GCP or Azure AI search or on AWS, these are all semantical search. It is not the the search, it's not the exact match search. That can be also done, but the essence of RAG depend on the semantical search. Means it is going for the semantical search result to give you back. It is not going for the exact words. okay, it depends upon the distance calculation in the vector database. okay, so now Also you can you can play it around, means if you have couple of more filter, but right now I don't have, right? So you can say I am searching for the document, let's say 1, okay, and if you fire up the query again, so automatically it will give you the, okay, it's not getting the absolute search, okay, fine, not an issue. Let's go for 6. Okay, now it's returning back. So this particular word SNBOS does not belong to document 1, okay, that is why the search was empty. Okay, now in 6 it found some kind of similarity matching between the word SNBOS. Okay, so again my search result, if I just refresh it for you, you will see it becomes 6 right now. So it is targeting this snb einstein.txt. okay, fantastic for now. So we have done this particular RAG search. So this is how the RAG will perform. Okay, now the question is that if I'm not satisfied, let's say my query is not like that. My query is like can you tell me something about SNBOS, okay, or who was SNBOS, okay, something like that. It's a kind of query that we used to give it back to the large language model like OpenAI and expected some kind of answer, right? Now we are performing the RAG because we want to give some kind of context to the LLM to give us the answer back. Okay, that is the purpose of it. So we are going to create a retriever. Retriever is nothing but an object which retrieves the result from the vector database by whatever query you are firing on. Okay, so let us create the retriever. And if you remember one of my video where I was using the ChromaDB, it is similar. It was like ChromaDB as retriever, it returned back other retriever. Now this particular retriever object does not belong to Google BigQuery or ChromaDB. It's absolute property of LangChain. Okay, so just remember how LangChain is abstracting our work to make the workflow similar. Even you change from today we are using BigQuery, right, for the vector database GCP BigQuery in the cloud, right? But maybe we are interested to use some kind of local database that I have already used my videos in previous videos, like the ChromaDB. Okay, it's a local setup, completely local setup. It does not go to the web. Okay, it's completely local setup. You install your laptop and you get the Olama over here and get some kind of model running on your local, so that you can perform the RAG locally. Also the what should I say, get the result from the local LLM back with the RAG result. Okay, so that can be also done, and we have already done those kind of example already in my previous video. So you can refer back to this particular channel and you will see those kind of videos already being present there. Okay, so now as we create the retriever, okay, so now here see, we need to create our chat model, because see, large language model is a kind of we are using this particular ChatVertexAI, the LLM model, as our chat model. So what exactly we have we'll be giving the query to the chat model and let it be responded back to us. Okay, that's the whole story about it. So let me create my model. Okay, now once this model has been created, okay, now this is the executing chain of LangChain. Okay, language using the LCEL of LangChain expression language. Now this part is very interesting, and it's going little bit deeper into the ocean of LangChain, where now we are starting to talk about LCEL. Okay, now what is happening exactly over here? As we'll be talking to the large language model, okay, LLM, so obviously we need some kind of template, right? So template will contain the information, means it will be passed to the LLM. What has been written over here in the template? Template basically comes under pure text format. Okay, so we have written that answer the question based only on the remember this word, only on the following context. Because see, if you do not give the context to the any LLM like OpenAI or ChatVertexAI, they are trained enough to tell you who was SN boss, right? So that's not an issue. But exactly what exactly we are looking for, we are saying the LLM that look here, I am giving you a particular context. Means this is the document. Context means the list of doc that we get out from our RAG search from the vector database, study it and also study the question, then based on the supplied document to you, which we are calling here as a context, okay, reply back to us. Do not do anything extra for that. Okay, so this become important. See, who was SN boss is a very generic query, and LLM are already being trained on those data. Okay, so that's not a good use case. But remember, when you are working for a particular organization, or you have some kind of custom data available to you, okay, that is not available in the internet. It is very business centric data. Okay, so the format is very business centric and all the information are related to that particular business that is not exposed to the internet. So obviously any large language model, okay, be it on Google Gemini or take anything OpenAI, okay, they will never understood your business context, because your context is not exposed to the internet, and those LLM are not trained with your data. Okay, so that is why when you are querying on your own data to get the answer, you need to pass the data to the LLM, so the LLM can understand this is my context, I have to read it through, this is my question, now I have to give it a output on GenAI basis, generative AI. Okay, so that's the whole story all about over here. Now this particular template has a variable called context and question. Okay, now this section you can write anything, okay, but this variable is very important. Okay, and you see when this context relate to this context and this question relate to this question. Okay, now this is called, this portion, this particular portion is called a template. Now based on the template we are formatting and prompt. That prompt we are going to supply to the LLM. Okay, the important factor over here is that whatever in the prompt mark as a variable, you need to be careful that you are passing those values to the LLM. Okay, so that is why I will come to the output parser later. Okay, let it forget now, this thing, output parser for now, but just focus on this particular area. Okay, let me zoom it out a bit. Let me see whether I can zoom it out for you. Okay, this section is very important to understand. So this is called runnable pass-through, runnable interface. Okay, so I can make another video on runnable interface totally, because it will take some time to understand the runnable interface. But for now, as we keep on going, runnable interface is something that takes the output from the previous and send back the output to the next. It's kind of middleware, you can say. As I say, that takes the output from, let's say we are having 1 as a function, 2 as a function, 3 as a function, 1 2 3 continuous functions. Okay, their signature are same. Remember, their signature have to be same. Okay, now the runnable pass-through or runnable interface, what exactly it is going to do is that it will take the output, means it will ask the A to execute. Whenever execution of function 1 is complete, it will take the output and push it back to 2. Okay, then again it will take the output from 2 and push it back to 3. Okay, so it's a chaining of the function. that will go on the executions. Okay, that is why those function which we are incorporating in this particular chain has to be adhere or has to implement the runnable interface. Okay, that is why this runnable keyword is coming on over here. Okay, so and this is the runnable pass through. What is runnable pass through? Runnable pass through is something that we are telling the function, don't tamper whatever mark as runnable pass through, just pass it to your next. Okay, now as you see, we are setting the context, retriever means whatever retriever is going to retrieve by the query. Okay, he is not going to tamper the query, rather query is set as a runnable pass through. So the retriever will take the question, will do the RAG in the vector database, and the end result of the retriever will be set it up as the context. Okay, that we are going to pass to the LLM. Okay, along with the question that user has entered. Now this is the chain. So this is our setup and retrieval. This is the prompt that we are going to pass to the LLM. This is the LLM model, and this is the output parser to make the output. Okay, now I understand this particular portion of the runnable interface or runnable pass through is a little bit trickier to understand. Okay, I will talk why it is more important. Okay, just let me execute this particular example. Let's say we are asking for who was SN Bose. Okay, this is our query. So let us run this one. Let's see what LLM is going to respond to us. So it's a generative AI, right? It will generate the next text. That is the capability of the Gen AI. Based on our things, the input that has been provided to Gen AI will try to give us a output in a normal human understandable manner. Okay, because RAG, see, this is the output from the LLM. Okay, and if you follow the output from the like this one, okay, so you ask the question, but it is returning the whole lot of document to you, right? So it is not giving you the particular answer, rather it is giving you the chunk of the document where LLM will interpret and give you the output. So let me copy this output, okay, so that I can show to you what has been returned back to by the LLM. Okay, it's just give me 1 minute. I just trying to copy it. Okay, just hold on. Okay, I think I have copied. Let me open up the let me open up the let me open up the and show you the text document. So this is the output from the LLM. So what was our question? Who was SN Bose? Now he is saying SN Bose, a renowned Indian physicist. Okay, so it is ended over here. So this is a line separator. He is integrating a line separator over here with a double dash. Okay, now contribution. So you can take it this way. This is another. Okay, here is a line separator. So you can have your own parser to separate those lines. Okay, so this is the total information that has been returned back by the LLM. Okay, and you see this all information does not contain on one particular document. Okay, we have 7 documents. So when we are querying who was SN Bose, essentially a maximum match will be returned. Okay, it can be 4, can be 5 documents altogether. Okay, now we are passing those documents to LLM. Okay, and those are document chunks, and he is understanding those document. He's getting the context. I'm setting this document as a context to the LLM. He's getting the context. He's also seeing the question. Now he's trying to match it together. Okay, means in a normal human language that if this is the question and this is the information do I have as a human being. Let's say we are a human being. Okay, so if I have given 4 papers, right, 4 text chunks, and someone asks me who was SN Bose. So how do I match that, right? So I will see the question, I will understand the question, then I will go, by my intelligence, I will search for the word SNBOS, I will see, okay, this is the thing, okay, this is the formulation, I will give it a summarization. So it is producing the summarization, okay. So this is the intelligence of the generative AI, okay. So as a human, long, from the very beginning, when we get the consciousness, okay, we develop the consciousness, okay. As a human, when we develop the consciousness, what is the consciousness? Consciousness make us aware about the, our outer facts, okay. So what I have been asked for, what is my task, what should I do? This is the human consciousness, okay. Now you see, this artificial intelligence has the consciousness, okay. So it can think like a human, okay, like a human. I'm not saying that it is replicating the human. No, it will take some time to come to that particular phase, but still now it is thinking like a human, okay. And it is saying that, if this is my question and this is my answer paper, okay, let me mash it back and give it back the answer to the audience. That's the purpose of it. Now we can discuss more on it. Actually, it's a very interesting topic, frankly, to you, okay. The consciousness of the AI. Now one thing I want to tell you about this particular thing, that's why I was focusing much over here, why I was after the runnable, okay. The primary reason behind it, that see, where we get our retriever, first of all, okay, we are getting the retriever, if I go up, you see, from the vector database, right? So today in this example, we are having only one vector database or vector source. Tomorrow, okay, in a real-time business case, okay, so the document can be PPT, can be PDF, having different data sources. It may not be a static vector database. It can be multiple vector database or dataset, and table will come up. So how do I process the data? Means if I, if every vector database represent every retriever, so if I have 4 vector database or tables, okay, and I have 4 retriever, right? So now 4 retriever, if I fire the query based on their data available within the vector database, they will give us 4 different output, okay. So sorry, I'm just taking some kind of water. Oh, just hold on, man. Getting some problem. Anyway, so what we are discussing, so let's say today we are getting only one retriever from one particular vector store, right? Now vector tables. Now if we have 4 vector generator, okay, or vector database over there, and where we can search the query and we get 4 retriever, then how do I pass those 4 retriever over here? Okay, that's not number one problem, okay. Now our question is very simple, right? It's a simple question, but what if I am going for extra parameters? At that point of time, you will see that in a real-time scenario, we need to create, this retriever will not work that fine, okay. We need to create our own runnable functions, okay, which can accept parameter, give it back to the LLM. So we have to create our own function, have to implement the runnable interface altogether, okay, to match with the LLM, push it back to the chain, okay, and then we can execute the LLM chain altogether, okay. So this is a very deep topic and it will go much deeper on the discussion part. So if you are interested to see how to work with multiple, when we have multiple vector databases, let's say we are having PDF, PPT, or some kind of textual document or link from the web, we are getting the data from the web, different sources giving different data, Okay, how we are going to summarize those up and send back to the LLM. Means every RAG output, if I have 4 RAG output over there, how are you going to merge those and send back to LLM? Okay, so if you want those kind of video, just let me know in the comment section. It will go much deeper into the world of the runnable. We have to understand the runnable very well, then we can understand the total workflow. Just let me know so that I can create another video on to this topic also. Okay, so for now, this is the journey that we have been completed. So again, I will share this particular this particular document to you, means this note to you on my GitHub, and I'll be embedding the link with the YouTube video, this particular GitHub link, as I do all on my videos. And if you go to the code, you will get everything from here. So this is all the thing that we have completed today. So what we have done in a summarized way: created the BigQuery data store, push the data over there, okay, with the embedding. We perform RAG search with custom filter for today also, and we send back the RAG to the LLM to get the response back from the LLM to the user. So that is the workflow, right? From storage, from bucket, GCP bucket, we embed the data, we take the data, we embed the data, push it back to the BigQuery tables as a vector database, store it over as a vector database. Okay, then the user perform a query, hit to the vector database. Okay, the vector database would yield a RAG output. The RAG output was sent back along with the query. Okay, not only RAG output, rather this RAG output and the query all together has been sent back to the LLM VertexAI chat. Okay, and thereafter it gives the summarization back to as a response to the actual the user who has fired the query. So that is the entire workflow. Okay, so thanks again friends for watching my channel. So if you like my videos, and if you want that I will continue my work, please like the video, give your thumbs up, put your comments or suggestion or any discussion topic that you want to have with me. Okay, I will be happy to discuss with you. And subscribe to the channel. So it will actually there is absolutely no money loss from your end if you subscribe to my channel, but it will give me some kind of moral boost and some kind of sense of engagement to you, all your friends over the world, so that I can go on to this journey. And this is the beginning of a bigger journey actually. So we are not going to stick with this LLM and RAG output. Rather, we are going to create a total infrastructure, total project from end to end, where we'll be uploading the files like PDF, PPT in the Google Cloud Storage GCP bucket over there. Okay, we'll be doing the embedding, we will be creating the vector database, okay, with the all the network configurations like the VNet, subnet, firewalls, all the things will be there. Okay, and it's a total project, end to end industry project that industry wants actually. Because you see, if you push back this is a simple solution, right? So if you want to host it on a cloud, how we are going to create your own environment over there, what the security mechanism that we are going to adhere over there. So be it on GCP cloud, be it on Azure. So I will do the same example on GCP as well as in Azure. When we work on Azure, we'll be using the Azure AI search over there. We'll be using Azure storage, Azure VNet, subnet, private endpoints, service endpoint to get the communication going. So we'll be creating one particular web app, okay, for the end user who will search the query over there, and this web app will communicate to the backend resources to get the result back from the vector database and show to the end user. So that's a total project that will be coming up onto your way. If you really like this kind of I'm trying my best to give you the explanation of the industry, what exactly the industry wants actually. It's not about you create the LLM, you create the info, it's all about from end to end. It means you have to understand the business use case. You have to do the design first. What component on the cloud we are going to use, okay, what should be your cost, what should be your security, what should be your resiliency, and all the factors will be coming up, okay, and how we are going to deploy that. Okay, from VS Code, yes, you can deploy that. From creating, on Azure, like, DevOps CI/CDs, you can deploy that. Okay, and what should be the security mechanism that we are going to add here. Okay, all the things will be coming up on the next videos. So stay tuned. Okay, be stay with this particular channel. Okay, so for now, this is the end of this particular video. Thank you my friends once more for watching this particular video.